The process of blending two different frames allows me to take a background frame and a foreground frame and combine them into a single blended frame. So in this example, I'm showing you that I will have one of the video IP cores actually generating this particular test pattern and another one that generates this particular mouse pointer value. A blender will allows me to combine this mouse pointer and overlay it on a background in here into a single image. There are multiple ways to do this particular blending. So specifically, we can do it in 4 different ways. We can do it either multiplexing, alpha blending, chroma key blending, or chroma key alpha blending. So let's dig into the details of all of them to see the differences. So the simplest of these is actually binary, what we call binary alpha blending or multiplexing. So, and here's a general equation that describes the functionality of this particular blending. And this is without any loss of generality. Usually you do it for the red and the green and the blue, but we're just going to talk about the red. So F represent the foreground pixel value, B represent the background pixel value. Remember, it's like when you have a core that actually usually have a foreground pixel value, and internally it's actually generating a background, or it actually take the background here and it generate usually foreground pixel value, and you're trying to blend them both together so that you can overlay these. So one method to do it is using this particular, what we call a binary alpha blending, and the reason why it's called binary alpha blending is because I'm using an alpha in here. So if you specify alpha either can be 0 or 1, you get that multiplexing. So for example, if you specify the alpha is 0, that technically I'm just basically canceling the foreground, and 1 minus 0 is 1. So I'm saying, well, the output should be exactly the background. So what you're effectively doing is you're getting the background. There's actually no blending in here. Similarly, if you actually do say, well, alpha is 1, that means you're actually getting the foreground, and 1 minus 1 is 0, that means the output would be exactly the foreground, and that's basically what you get. So there isn't an actual blending. So it's kind of you're either bypassing the functionality, or you're not bypassing it. It's just a bypass functionality. Alpha blending allows me to take this a little bit further. So instead of restricting alpha, it's the same exact equation. I have foreground and a background in alpha. So instead of restricting alpha to be a number, either 0 or 1, I'm basically allowing it to be a continuous number between alpha and 1. So let's see a few examples in here. So an example, if you say alpha is 0.25, that means I'm telling you, well, the foreground should be 0.25 and I want the background to be 75%. And if you take a look at it here, it's basically showing me more background, and the foreground, which is the mouse pointer, is really faint. If you increase the alpha to 0.5, like you see in here, you'll see it's about 50-50%. So the opacity level is 50% for both of them. Now, if you increase the alpha to basically 75%, that tells me that you want to show the foreground 75%, basically with a brightness of 75%, the mouse pointer 75%, and the background 25%. And you get to see, this is now, it's more blending. So I'm seeing both the background and the foreground with different opacity. And the alpha can be interpreted as the opacity of the foreground. So the higher the alpha, the more opaque, basically, the background is. Okay, or the foreground, the more opaque the foreground, which is basically less transparent. So like if you take alpha all the way to 1, you'll only get the mouse pointer because it's really opaque, it's not transparent. And this is what alpha blending is. However, if we're dealing with a mouse pointer one, it's really not what we want. What we want is we want the mouse pointer to be perfectly overlaid over the background without affecting the rest of the background. So for example, why would I need to make the background so faint in here and here and here and here? I don't want to. So then comes the chroma key blending, and the chroma key blending basically mimics the green screen effect that we know from video production. So in here, what we have is, if you remember, the foreground had basically the pixel value in here and everything was 0. So we specify something we call a chroma key. I mean, in a green screen production, that would be the green color in here will be the black color, for example. And we'll say, okay, if the foreground color does not equal the chroma key, just basically output that foreground color. Basically output that, which is the mouse pointer. However, if the foreground color, basically that black one in here, let me just show you if that here, it's actually the chroma key, which is in our case is actually black, just output the background color, and that's exactly what happens. So the output either is the foreground color or the background color. There's actually no blend, like it's not really blending. I'm not basically making one opaque or one more transparent than the other. And that's actually really convenient. This is what we specifically want. This now I have a mouse pointer that is overlaid over some sort of a background, and that's perfect for our purposes. In certain cases, you might want to make one more opaque than the others. So what you do is basically, if it is not For example, you can use this particular equation and you can basically make that particular mouse pointer like a little bit more faint, like more faint or less faint or whatnot using this particular equation. So for you're telling me if it's not the chroma key, basically it's not the green color or the black color, I want you basically to mix them or blend them in a very similar fashion to, or very similar way of alpha blending, the normal alpha blending. So the blenders that we've seen before actually perform one of these functionalities, but more likely we're going to see this functionality implemented because it's really useful.